So after I put the AstroZap, it's a heater and dew shield, on my telescope, what I've been having to do to kind of get dust cover is take the original optical tube cover, which would normally go like that, put it inside this guy, and I've been clamping it on with these clamps to make sure it doesn't fall down and hit the glass. I don't really feel like that's a great long-term solution, so I 3D printed this guy that will fit over the top here and just kind of friction fits on there. Now if I were to point this straight down, it might fall off. It's not on super tight, but I never point this straight down because it's on a wedge. So this is about as low as this guy can get. So that's going to be my new dust cover when this guy is permanently kind of left on my optical tube. So the problem with having a telescope with the aperture bigger than the bed of your 3D printer is that you need to start printing things in sections if you want to make large covers for the optical tube, or Batonov masks, or tri-Batonov masks, and so forth. Alright, so before putting the glue on, I dry fit it, figure out where I'm going to put the clamps. I specifically have, these guys are mostly for strengthening, but they also make a great place to clip, and you can use kind of like something like this up where it's tall. Where it gets narrow down here, you have to use something smaller like that, or if you want a little more strength, these binder clips I've found, put quite a bit of pinching force there. Now, up and down, we're really using the flat base here, so it has to be something flat, silicone matte, so it won't get glued to your tabletop. And then back here, I have put in these little groove clips, and the only reason I have those designed in really is so I can put a clamp in there and clamp this piece together here like that. You can see I put a lot of clamping force on there. Actually, I had some layer lines separate and click there, but when I put the super glue and glue that thing together, that's going to fix itself. And so essentially this guy, if you put it in like that, will kind of keep front to back, and I'm putting it into the corner of this 90-degree angle here to basically align everything. And I think it's going to be easier to do 2 quarters, put those together into a half, and then put the 2 halves together into a whole. So for putting these 2 quarters together into a half, I have a straight edge here which is clamped down so it won't move. I've actually clamped this piece down into the corner here, so it's probably not going to move. It's poking up a little here because I'm pushing it down there. So I put this heavy battery on top. And basically we have this guy ready to slide in like that. And I just need to clamp it and glue it. It's a little wiggly here. This thing can go up and down a bit, so I'm going to try to get those guys kind of at the same height on the top and then clamp it. When it came time to put the 2 halves together, I found out that I'm off by maybe a degree, maybe 2 degrees here. So it flips back and forth like that. And so what I'm going to do is I'm going to glue this quarter, or this half of the thing, together over here, and I'm going to leave that gap in there. And then maybe we'll get out the 3D pin and just fill this in with some filament or something. Still not entirely certain why I got this gap here. Maybe I just wasn't careful enough gluing a couple of these sections together. It's much less than 8 degrees, so I'm pretty sure each of my sections here is actually a full 45 degrees. But I just hit it with a 3D printing kind of pin to kind of fill in the gap and glue that section together there. I might go back and hit all of these joints with kind of a flat bladed hot iron just to kind of melt those joints together a little bit more, especially on the inside here. just going down these things on the inside, every place they join together, kind of to melt these things together, give them a little more structural, support. It feels pretty strong, but you just heard a little click there somewhere. So I mean, it's fine for a lens cap, but just to make sure it stays together if I drop it on the floor or something. So I have my plastic welding soldering iron on my soldering iron. This is used only for welding plastic. My soldering iron is set to 480 degrees centigrade, and this is the seam that's just super glued together here. And so I am going to hit that with this soldering iron and just follow the seam along. And the nice thing about this is the soldering iron pretty much just follows that seam because I kind of have a V blade in there. And so when you get done, it's not perfectly even, but it mostly follows that line. And so it looks pretty reasonable. It's not going to look obviously horribly icky and wrong. And it definitely seals together those two pieces of plastic. So melting ABS plastic is typically an outdoor activity, but you might hear all these fans I have going on in here. So I recommend you do it outdoors unless you have some good exhaust and filtering fans. And that's how I assembled this guy.